This is the case walkthrough video for the Microsoft Excel Collegiate Challenge Round 5, Bit of Music, Varsity Edition. Let's get started with the premise of the case. You're a DJ getting your setup ready for your next big gig. In digital music, instruments communicate via the musical instrument digital interface. Communication happens with bytes, i.e. 8 binary digits such as 100, 10010, exchanged from a controller to the instrument. The instrument has to identify if the message is addressed to it, and if so, what kind of action it should trigger. Keep in mind that a byte is 8 binary digits and a nibble is 4 binary digits. One of our tasks will be to convert from bytes and nibbles into decimal numbers. So let's look at what makes up a MIDI binary message. The first 4 digits, so the first status nibble, will indicate if the instrument's turning on or off or doing a control change. Digits 5 through 8 will indicate the channel. Digits 9 through 16 will indicate the key, and digits 17 through 24 will indicate the velocity. So let's jump right into level 1. This level is asking us to convert from status nibble 2, which will tell us the channel, to the channel number, which will be a decimal number. We're going to use Excel's built-in binary to decimal function, bin2dec. All we have to do is feed it in and copy down. Easy as that. Now level 2 is asking us to split this longer message, which is a note on message, into 3 sections, and then add those numbers together without converting the decimal numbers. So the first thing we have to do is split up the string. We're going to use TEXTSPLIT, and we are going to divide it into 3 strings. This second argument here, the dash, is what we're splitting the string on. Now we want to add all of these. Right now, if we were to add them, we will get 0, because Excel is reading these as text, because that's how it can handle binary. So we need to wrap this in an int function to make them numbers. And there we go, we've got an answer. I'm just going to copy this over into our answers cells and copy down. Level 3 is asking us to figure out which instrument this message is addressing. So we're going to need to find the channel within this message and look that channel up in our lookup tables, which are here. One of the first things I do with every case is to make these tables into named ranges, which I usually do with Control-Shift-F3. However, in this case, there's 2 different columns and 2 different tables named note. And that won't work with named ranges where we make the names automatically. So I'm going to change one of these to instrument notes, just so that they have different names. And make my named ranges. Again, this shortcut is Control-Shift-F3. Now that I have my named ranges, I'm going to go back here and we are going to select out this part of the string that'll tell us the channel, which, if we remember back, is digits 5 through 9. So our start number is 5 for our mid function, and we're taking 4 characters. Now I want to convert this from binary to decimal, and it's channel 2. So all we have to do is a quick XLOOKUP, channel 2, and return the instrument. Drawbar organ. Make sure that it matches the example, which it does, and copy down. Typing too quick. There we go. And this little NA here is just because I've copied it past one which doesn't have the message. Delete that out just to keep this a little bit neat. Now level 4 is very similar to level 3, but there's a slight nuance. All the drums are on channel 10, but there are multiple drums, so how do we know which one is being triggered? We can do that by looking at the note that's being played. So, if a message is addressed to channel 10, we'll have to do a little bit more research, and we'll have to look at what note's being played to be able to determine what drum. Now we could do this in line like we did with the past 3 levels, but I'm going to make a new sheet and use a data table just to keep this nice, and it'll help us later on. So I'm going to start by typing in the name of the example that we want and doing an XLOOKUP on the whole B column of the case sheet. And returning the whole G column, which will give us the message. I like just copying the message down one row just to make things a little bit nicer for myself. And adding in some headers here. So we want our status, our channel, our key, and our velocity. So we know our status is going to be the leftmost 4 characters. So we're going to use the left function. The channel we just did, so that's mid starting at 5 and going over 4. The key, we start at 9 and go over 8 because there's 8 digits in a byte. We start at 9 and go over 8. Fixing my mistakes here. And then finally we can use the right function to get the rightmost 8 characters. I'm going to copy our headers again, just so I keep track of what I'm doing. Status, we don't need to worry about right now, so I'm just copying it over exactly. Channel, and the rest of them actually. We're going to use this binary to decimal function and copy it over. Now, for the key, we want to know what the key is, so I'm going to do the XLOOKUP here, just so that I don't have extra columns messing things up. So we're going to look up the key and return the note. So 0010000 plays the key C2. Now we can determine the instrument. We're going to do a quick if statement. If the channel's 10, then we want our XLOOKUP to be on this key. And we'll search instrument notes and return the instrument. And if it's not 10, we just want to look up the channel and return the instrument. Kick drum, which matches our example. I'm going to copy it down here. And now I'm going to copy all of our case numbers. But first, this is kind of a weird one. We have 2 examples, so I'm going to check and make sure it matches for example B. Guitar electric, guitar electric. Now, to make the data table, we have this setup that looks kind of like this. We have all of our task numbers along this side, and the function that or the result that we want our data table to output at this top. I'm going to highlight the whole thing, and you can either go to Data, What If Analysis, and Data Table, or you can use the shortcut Alt-A-W-T. And then because we have our electric guitar in the column, we're going to move our column input to be the example number. And there we go. It's done this little process for all of those levels. And then copy them over. Now, level 5. This time we want to know the average velocity for only note on messages. This is pretty similar to what we just did in level 4 with a few changes. So I'm actually just going to copy over all of this to level 5. Remember to change the example from level 4 to level 5. So the first big difference that we have to address is instead of it just being one message, we have a bunch of messages that are broken up with semicolons. Once again, we can use the TEXTSPLIT function, except this time, instead of having a column delineator, we want a row delineator, which will be the semicolon. And then we can change these to make them dynamic arrays, which will spill them down the whole length. I like doing this just so that I don't accidentally forget to drag a function down too far, but unfortunately, we will have to do that because our nice binary to decimal functions do not play nice with array formulas. So I've copied all those down. Now our statuses. We want to know if it says on or off. So I am going to make a switch function. The switch function takes in an expression and checks it against a set of values. It's like an ifs function, but it works. It's good for when you're checking one number against many different cases instead of potentially many different numbers against one case. So we're reading in our value. If it's 1001, we want that to say on. If it's 1000, we want it to say off. And if it's anything else, we'll just ignore it and put in a blank string. And there we go. And now we're just going to do a quick average ifs. Our average range is going to be our velocity, and our criteria range is going to be this on and off column, and we only want ons. We're going to do the same process with the data table as last time. Copy this over, create the data table. And now, did anyone notice my mistake? I haven't rounded. The problem asks us to round to the nearest integer, which is why I will need to wrap this in the round and round it to 0 digits. There we go. Copy it over once again, and on to the next level. Once again, not too different from what we just did in the last level, so I will start with copying over what I had just done. Copy this to level 6, change the example, and whoops, we're using hexadecimal now. Our string splitting is not going to work quite right with hexadecimal because instead of there being 16 digits to a byte, 8 digits to a byte, there's now only 2. So I'm going to take the left 1 digit for a status, because instead of 4 we have 1. Our mid, we're going to start at the second digit, and we only take 1. Our key, we start at the third digit and take 2. And our velocity, we just want the last 2. So I'm going to check the second one because it doesn't have any digits repeating in a row. We want 9C3C5, 35, which is what we have. Now our switch function is looking for 1001, which isn't there, but we know that it is 9 in decimal or hexadecimal, so we can just change that real quick to a 9 and this to an 8. And our channels, we're doing binary to decimal. We just make that quick change to hex to decimal on all 3 of these. And copy down. Now let's go back and see what we were looking for again. We're looking for the note that has been used in the most messages. So we want a list of all the notes that have been used uniquely in this message. So we'll check the keys, and we have this list. Now we can just use a COUNTIF. We're going to count our range of keys, or if it equals any of these, and it gives us this lovely output, this frequency table, which we can use to see that C2 has been played the most. We can figure this out with a formula using XLOOKUP again. We're going to XLOOKUP the max value from our frequency table from that column in the table and return our notes. And this is all dynamic arrays so that if there's less notes played in one level versus one game than the next one, it will adapt. There we go, C2. Data table again. Bam, done, and copied. We're on to our last main level. This time we have a bunch of hexadecimal that's not split up with semicolons, but we can handle that, we'll get there. And we want to know which instrument is never addressed. It's also not that bad. We'll make a new one, copy over once again. This is just very nice because I don't have to repeat a lot of my work, and as you can see we are flying through this. And change our example number. Now, I'm going to move this down a little bit so that we can see how to split this large piece up. I want to go digit by digit and split it up so that it's one long dynamic array. So I'm going to do that with mid. I'm going to feed this text in, and we want to take each start number, so 1, 2, 3, and so on. We can do that with sequence. We just need to know how many characters are in this string. And we can find that out with len, or length. It's that simple. And then we only want 1 character for each of our splits. So this function will split out 1 word or a string into each character individually. And because right now we've got this spill error because there's something in the way, I can really easily change that so that our sequence function goes horizontally by adding a comma there. Now, I want to wrap this all back together so that there's only 6 characters in a row. We're going to use WRAPROWS for that on the whole dynamic array, and we want 6 characters in each row. Like that. And finally, we are going to concatenate it all back together using by row. This will go row by row and perform the function that we want on it, in this case, concat. And there we go. I'm going to copy this here where we used to have the text split. Easy. And then copy these functions down again, unfortunately. So this time we want to know what instrument hasn't been addressed. We don't have a column right now for instrument, but we did in level 4. So grab that from level 4. And because we're using the same inputs each time, it will just work. Copy that one down. The last piece here is that we need a list of all the possible instruments. Good thing we've got a named range for that called instrument. That is a list of all the instruments. We're going to use a COUNTIF exactly like we did in the last level with our instrument range and our all possible instruments. And this time we want to know which one has been addressed no times. So we're looking up for 0. And then one more data table. Just like that, we are on to bonuses. First I have to copy it over. Getting a little ahead of myself. Ready for bonuses. Our first bonus is we want to know how many ones there are in the level 1 messages. Now, there's an easy way to do this, but we're going to make it slightly more complicated, and we're going to make a lambda for it. Having a lambda that counts characters is one of my most used lambdas, so I'm going to show you how to make that. First, since we are looking for how many ones are in all of the level 1 messages, I'm going to copy all of our level 1 messages over into another sheet. Then, when you want to count the number of characters, the most efficient way I found to do this is using substitute, where we can feed in the text and we want to look for all the ones and replace them with an empty string, which shows us what this looks like without the ones. Now, if we take the length of all of the original ones minus the length of all the current ones with the ones removed, we will know how many ones there used to be. Now, I've made a real mess of this. I'm going to undo some of this. And we are going to go back and do that process in a let. I'm going to start by defining a named range, which will be range, and one called letter, which will be the letter or character that we want to replace. We'll just put that there. And I want to return just the letter for right now, which, because that's empty, is 0, and now it's 1. Then, after we've done our initial declarations here, I'm hitting Alt-Enter to make a new line, just so I can keep this a little bit clear. We are going to make one called substituted, which will be our substituted function. Substitute the range, where our old text is the letter, and our new text is blank. And we would just want to know how many characters are in that, so the length. Next we want to know, let's actually return that so we can see how it looks. See? So there's a 0 left, there's 4 zeros left in this line, there's 2 in this line. So we want to subtract that from the number of letters that we had initially in range. Which looks like we had 3 ones, we had 0 ones. And since we don't really care about each individual line in the range, we just care generally, I'm going to wrap this in a sum. And there we go. Now, right now it's just a let, and we want to make this a lambda, which is a function that we made ourselves that we can call later. So I'm going to wrap it in lambda, and we're going to want our input parameters to be range again, and letter again. And then delete those from the let function so that they're not called twice. This will give us an error right now. Oh, it's because I deleted the let statement. That will give us an error right now. That's because we fed nothing into this function. We can put our arguments here in this little parentheses next to it. See, 44. And then we can save this. You can either use a plugin I have like XL Labs or OA Robot to define your lambdas, or if you don't have one of those or your work doesn't allow one, like my work doesn't, you can always just go into the name defined menu and define a new name. I'm going to call this count characters or count char, and then refers to and paste in our function. So if I call count char 44, let's go back to our bonus and we can do that over here. Put in our range and we want 1. Ta-da! So now we want to know what letter appears exactly 22 times in level 3 answers. So let's grab all the level 3 answers and copy those over to this new sheet. Call that one bonus 2. So right now, if we were to make a list of all the letters, we would run into a problem. Because on this first one, we would count capital A and lowercase a separately. So I'm going to convert these all to uppercase, and all we need now is a list of all of the uppercase letters, which we can do with this nifty function. We're going to start with a sequence of 26 numbers, because there's 26 letters, and we are going to start at 65. We are starting at 65 because that's the Unicode code for the letter A. So then, if we wrap this in char or unichar, we have a sequence of the alphabet. We can use our count characters function again. And I didn't anchor my range. Let's anchor that. There we go. And we are looking for 22. I can just see it here, it's an I, but we could do it with an XLOOKUP as well. Now, in level 4 messages, we want to count the number of zeros, subtract the number of ones, and divide the result by 2. Which letter appears exactly that many times in level 4 answers? So, I'm going to cheat a little bit. I'm going to copy our level 4 answers into what we just made for bonus 2. We did most of the work already. Why not use it? And then I'm going to copy over all of the level 4 messages so we can do the work next to it. And I'm going to rename this to bonus 3 because I've overwritten a lot of my work. I should have just duplicated this, so I'm actually going to undo, make a copy, and call it bonus 3. Backtracking a little bit here, apologies. And then copy over the answers. So, we're starting with the number of zeros minus the number of ones divided by 2. So we're counting our number of zeros. I'm anchoring my range this time. So we want this number divided minus this number divided by 2. Which is 20. So which one of these letters appeared exactly 20 times? R. Again, if this was longer, I would be doing this with an XLOOKUP, but I can see really quickly that it is just R. So, on to bonus 4. What is the sum of all the velocity values in level 4, excluding the example? We could do this with a whole nother sheet and grab all the velocity values, but we already did all the hard work in level 4. All we have to do is change what our data table is pointing at from the instrument to the velocity and sum. 1427. 1429. I can read. And there's only one bonus left. In the level 7 example message, after converting all the hexadecimal values to binary values, treat each binary status byte as a regular number. What is the sum of all the status byte values? Now that sounds like a big, complex phrase, but it's not actually that bad. And we're going to start with our level 7 example. I'm just going to copy it straight from here, cheat a little bit, and paste it here. Now, we're going to do our wrap rows just like we did from level 7. I pasted things into the wrong cells, but there we go. So, and get all of our status bytes, which is our left 2. And just to show that the status byte, because I think we only talked about these in terms of nibbles, that is part 1 and part 2 combined, digits 1 to 8. We just convert these from hexadecimal. Oh, getting a funny visual bug. From hexadecimal to binary. Forget that it only takes 1 at a time. We can't do the nice dynamic array thing here. Convert these all to integers. Dynamic arrays work now. And sum them. And there's our output. Copy it over. And just like that, we're done. It looks like we are at just under 30 minutes. So plenty of time remaining. But this isn't the first time I've done this case. So if you enjoyed this case or you found it a little bit easy or something that you want to expand on, I highly recommend trying the Microsoft Excel World Championship case designed by Julien. It was an incredibly fun case. It's actually the case I qualified on. It's one of my favorites this year so far. So I hope you learned a lot from this and had fun. Thanks.